first half of class, or first mod of class, first fourth of the class, if you will. Let's talk composition of functions. So what I would like you to do right now is, here is f of x, here's the inverse of f of x, and there's g of x. So I want you to think back to your composition of function type things, and I want you to find me f of g of 5 and f inverse of 10. So you can do those two.
Is this like broken?
No, batteries are dead.
That's stupid.
Somebody hit me up. How do I find f of g of 5? I plug in what? I plug 5 into g, right? So the first thing that we have to find is we have to find g of 5. So g of 5 is going to be 5 squared plus 7. That's 25 plus 7. That's 32. Correct? Okay, then what?
Plug it in.
Plug what in and where?
For x on the f of x.
Well, what?
Didn't I say 32?
You did not. You just said plug it in.
I thought that was presumed.
Oh, no. Okay, so I do what, Lan?
Do you do 32 times 5?
No. What was yours, Jay?
You basically put the 32 in for f of x for x.
So now we find f of 32. Because g of 5 is 32, we want to find f of g of 5. If g of 5 is 32, we find f of 32. So that means I'm going to plug it in, plug 32 in for x in there. 2 times 32 is 64. 64 plus 3 is 67. So f of g of 5 is 67. Yes, sir.
Could you just plug the g of x equation into the f of x equation? Like,
And then plug in 5?
yeah.
I mean, you can, but if your equations are a lot more complicated, then that's going to Mosinee through Rhinelander. Okay?
I
Right?
just ripped my paper.
No, I just want you to read it.
Oh! Oh!
Okay? Alright? F of F inverse of 10. What do we do?
Start by f inverse 10.
Start by F inverse of 10. What is F inverse of 10?
Is this thermometer accurate?
Then I find F of 7/2. So that would be 2 times 7/2 plus 3. 2 times 7/2 plus 3. Does that make sense? Will that always happen? I started by plugging in 10, and the result I got was 10.
It should be, yeah.
Not opposites. Inverses, yep. If the functions are inverses, will that always happen?
Yeah.
Yeah. In polynomial functions, that will always happen. Okay? Alright? Let's kick it up a notch now. Let's take that and let's go to the trig world. Okay? So now let's use inverses using the unit circle. Okay? We want our answers for our angles in radians. If it's number answers, we want exact answers. Okay? Which means basically, if the answer that we get is the square root of 3 over 2, we want the square root of 3 over 2. We don't want it to round. And we want our answers in radians, so that means we're going to have pi's all over the place. Okay? So, same concept as before. the first thing that I'm going to do is I'm going to do this part in here. Start on the inside, work your way out. Okay? So this is saying, what is the arc cosine, oops, I forgot an extra C, of 1/2? Well, from what we learned last week, arc cosine is which half of the unit circle? Top or right? Arc cosine. Cosine is the top half. Okay? Cosine is the top half. Sine is the right half. Okay? So top half of the unit circle, where is cosine positive 1/2? Pi over 3. So then what this is really saying is we want this to find, or we want to find the sine at pi over 3. Because arc cosine of 1/2 is pi over 3, so we need to find the sine of pi over 3. What is the sine at pi over 3? Square root 3 over 2. Good stuff, exactly. Huh? Cosine of inverse sine of negative root 3 over 2. Sine, inverse sine, where do I find those?
Right half.
Right half of the unit circle. Where on the right half of the unit circle is the inverse sine, negative square root 3 over 2? Where? I've heard 3 different answers. Now I've heard 4 different answers. So far I've heard 5 pi over 3. Let's take them one at a time. 5 pi over 3. Do I like 5 pi over 3?
No.
Why not? It's outside of my range, right? Or my possible values, let's say. Yep. Okay. Right? So we don't like that one. Okay? Negative pi over 3 was the next one that I had heard. Do we like that one?
Wait, what is it? Is it the one that I said?
I just said that yours was the next one that I heard, was
Oh.
negative pi over 3.
I like that. I'm rocking with it.
You think that one's right? The next one I heard was negative pi over 6. I don't remember the third one I heard. Okay. Which one do I like the best? Negative pi over 3, because that's where the sine, which is the y values, is negative square root 3 over 2. So then here, we're looking for the cosine at negative pi over 3. What is the cosine value at negative pi over 3? 1/2. Yes, ma'am. In these cases, yeah. Yep. And so like in the next style, the next brand, if you will, then we're gonna, because these we're finding the numbers. Now we're gonna switch where the inverse is. Now the inverse on the outside, then it's finding the angle. That's when this happens. Yep. I don't think so.
What did you say that
It says it's 92 degrees.
Okay.
It might be
Right?
right here.
right there?
So you guys find me those two. Sine at pi over 3. Sine of pi over 3.
Square root of 3 over
Square root of 3 over 2. Inverse sine of square root 3 over 2. Pi over 3. Right half of the unit circle. Where is sine square root 3 over 2? That's at pi over 3. Now, Jack, you had an interesting observation. What was your original thought on this particular problem?
Well, this one was just like the inverse sine and the regular sine just cancel out.
Cancel each other out?
Yep.
Kind of like on that last one that we did, the algebraic one that we did from the start. F canceled out F inverse. Okay, all right, I like it. Okay, so what should this next one be then?
Negative pi over 3.
Not according to your logic.
Well, you have to keep it in the
According to your
range.
logic, it should be 5 pi over 3.
C, but I was just presuming that it would stay in the range.
Okay, all right. So it doesn't always necessarily work.
I mean, yeah, but
So no, it doesn't always work.
it
Doesn't always work.
They're the same
Just to
thing.
answer
though.
the question, it
They're
doesn't
the
always
same
work.
thing, though.
You know that it doesn't always work. And so you're trying to justify it. So it doesn't, it works. That's why I said before, in polynomial function, when you take the inverse of the function or the function of the inverse, those just cancel each other out. Okay? But in trig, because we have restricted values, that doesn't work out. Okay? So this is, in fact, the sine at 5 pi over 3 is, in fact, negative square root 3 over 2. However, the inverse sine of negative square root 3 over 2 is not 5 pi over 3, it's negative pi over 3. So we have to be careful when we're taking the function and its inverse inside of one of them. Okay? All right. Now, what I would like you to be working on, and you can work on this as your table group, okay? I would like you to be working on the white packet. Okay? There are the first 3 pages. So the first page deals with refreshing your memory about inverse cosine and inverse sine. Then pages 2 and 3 deal with the inverse tangent function. You will be discovering the inverse tangent function today on your own. Before you get to the 3rd page, I strongly encourage you to check with me to make sure that your inverse tangent graph is correct. Okay? So check with me before you go on to page number 3. Okay? And then the last page, page number 4, is just some final exam practice type problems / ACT practice type problems, type different kinds of questions that we pulled off of different type of tests that we've taken.
What's going to be on the final?
Everything from semester 1.